here we are. So far for me, this is probably as good as it gets, all right? Science enthusiasts, I hope you are wearing a parachute and you are buckled up because it's about to get really bumpy. For those of you that cannot change your mind when you're presented with new evidence, what a rough road it must be. We've had a bumpy encounter or two over the last couple of days. I'm not going to deny it. I just can't keep going over the same old stuff. I can't. It does my head in. It's like, seriously, you need to start thinking critically. Stop believing the narrative and start thinking. And I'm going to show you why tonight. This, as far as I'm concerned, is one of the good ones that we found, okay? Real quick. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto is a planet, okay? It's the order of the planets. The amount of time it takes for the sun to reach Mercury is 3 minutes. It takes 6 minutes to reach Venus, 8 minutes 20 or 8 minutes 19, depending what mood she's in. Hey Alexa, how long did it take for the sunlight to reach planet Earth?
Here is what I found from reference.com. It takes approximately 8.3 minutes for light from the sun to reach the Earth.
See, she's saying 8.3. That's really tacky if you're going to launch something, isn't it? Oh yeah, NASA, 8.3 or something, thereabouts, if they were going. 30 minutes to reach Mars, 43, Jupiter. Key, it takes 1 hour 20 for the sunlight to reach Saturn. Remember that number. We're not going to worry about Uranus tonight, or Neptune, or Pluto. Pluto, it's nothing against you, it's just you're at the end, and the other two aren't in it either, okay? It's not personal. I know you've had a rough trot. I'm going to put it right. What we have here, Mercury, Venus, Earth, right? This is the order from the sun. Mars, Jupiter, Saturn. We're not worried about the other three. So what we have, let's go for the axis spin. Mercury, it takes 58 days, right, for Mercury to spin once on its axis. It takes 243 days for Venus to spin once on its axis, and it spins clockwise. It's the only planet to spin clockwise like that, okay? It takes 243 days of our days for it to go on its axis once, right? It's a long day. Us, we know. Mars, it takes 24.6 hours. Jupiter, it takes 9 hours and 55 minutes. It's the fastest spinner, right? It's the fastest spinner. Saturn, 10 hours and 33 minutes. We didn't do Uranus, Neptune and Pluto because they're not in it today. And what we have here is Mercury, Venus, Mars, Jupiter and Saturn. Now, these are the five we're concentrating on. On the news not long ago, we had news that 5 planets were going to line up. Mercury, Venus, Mars, Jupiter and Saturn. Remember that? Now, if Earth is third away from the sun, how can Mercury and Venus be in front of Earth for us to then see Mars, Jupiter and Saturn? It sounds not possible. So what happens, here are the orbits around the sun. It takes 88 days for Mercury to orbit the sun. It takes 225 days for Venus to orbit the sun. So this is fast. Like it goes around once, twice is 160, 176, and that'll be 340, 52. So Mercury orbits the sun 4 times as fast as we do. So every now and again, because they're all in different orbits, Venus as well, they're all in different orbits, right? we end up somewhere like here, right? Coming around from the sun, and Mercury will find itself here because we're on orbit like close to the, it's hard to explain, but our orbit, as we go around the sun, and we go round, when we're around the corner, Mercury could be doing an orbit, even though it's closer, all of a sudden, it's in our line of fire away. So that's why we have to see it early in the evening, because of the sunlight on planet Earth round the back. And it just so happens that Venus as well finds itself in that orbit where we find ourselves kind of behind the sun, all right? So it's a funny angle. It doesn't happen often. And then we see Mars, Jupiter, and Saturn, okay? Now this is key. Sports enthusiasts and science enthusiasts, buckle up, okay? This is where everybody gets to decide for themselves. This isn't about following the crowd. This is about trusting your own judgment about something, okay? Trusting your own judgment about something. Now, me, I don't like the speed of light. I've never liked it. And the more I've looked into it, with this OL from Denmark, all right? It takes, he looked up, there was no power, 1676, no power, no, nothing, right? So he's up there like this. Okay, this is Jupiter. And it depends what we're doing, and we're going around, we're orbiting, we're spinning. Oh, it's gone out of sight again. Damn it. Oh, there it is again. Another night. Oh, it's clouded now. Oh, yeah, there she is. Right, 3 weeks later, got another good view. But because it takes 11.8, let's just call it 12, okay? It takes 12 years for Jupiter to orbit the sun once, all right? In that 12 years, obviously, we've gone around 12 times. Now, for any reading to be accurate, you'd think at least one complete orbit of Jupiter around the sun is going to be required, even though it's the moons orbiting around Jupiter that this guy is looking at. Jupiter still has to go around the sun once, and it takes 12 years. Now we're going around, like, and Jupiter's coming, and, you know, and then he's looking at the moons that are also, so all of a sudden, we're spinning, we're orbiting the sun, we're spinning on our axis. Jupiter's the fastest spinner on its axis. It's got how many, Alexa, how many moons has Jupiter got? It's 80 something, isn't it?
Jupiter has 80 moons.
80 moons, sometimes it's 86 something. Look, Jupiter has 80 moons. Yes, science enthusiasts, I've told you to buckle up, all right? It's gone for 12 years, and we just happened to pass it 12 times. So where is there enough of a pattern, right? Where he said, oh yeah, last time it was there. Would it not take 11.8 years for him, for the first time, to say, ah, there it is, one. And now, what is it he's going to measure? How did he measure the speed of light? All right? I don't want to hear it, okay? It's ridiculous. There's stuff written down in some of the articles that people are copying and pasting it to me, right? Yeah, but look at this. Look, what? says, yeah, he used Jupiter's moons, but it doesn't say how. It's like, that's all they need. They don't need the details. They don't need the nitty gritty where the facts are to be decided, right? Where logic and common sense go, no. How is that even possible? And that is where I'm at. So no, I'm calling that as bogus, all right? 1676 for the speed of light, and it's stuck. Let's have a look at that, okay? Let's have a look at that. That special time of year, all right? So I was going to do it like a window, so you're at home, right? And the news, ABC, gets one thing right. In the sky tonight, you'll see Mercury, Venus, Mars, Jupiter, and Saturn for yourselves, ladies and gentlemen. It only happens once every boop, 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 boop. Don't miss it. Okay, we're always up for a 5. Sometimes it's a 4. So even though we're supposed to be here, right, we are behind all of them, right? Let's just say here, because of the sun that's behind us all. So the sun is behind us all, shining that way, which is why we can see the planets, because they are lumps of rock. The only reason we can see the planets is because the sun's shining on them, all right? Another key thing, the only reason we can see these planets, right, is because the sun is shining on them. They're not stars, they don't shine naturally. When you see Venus in the sky, it's not Venus shining, it's the reflection of the sun onto Venus that we see, the same as our moon, okay? So don't think for a second that, I've heard it before, oh yeah, Jupiter's shining, like it's not shining. It's a reflection of the sun. These are rocks, well, these are gas planets, all right? But irrelevant, all right? They do not shine. The sun is reflecting off of them. Right, now, if the sun went out behind us, for whatever reason, Ergon got hold of it, the man didn't pay the electric bill, sun goes out, it's out for 24 hours, it comes back on, all right? What they're saying is it takes 3 minutes for that sun, right, to travel 52 million kilometers. Sun comes back on, 3 minutes, all right? Now Venus, so remember these, Venus, it was 6, 13, 43, 1 hour 20 for Saturn. So Venus, that's 6, so it takes 3 minutes, another 3 minutes to get to Venus, all right? And we know it takes 8 minutes, 20 or 8.3, depending on what mood she's in, to reach Earth, but we're back there. So Mars, it takes 13 minutes for the sun to reach Mars. 13 minutes, right? So Venus is going to be lit up at 6, right? And it's going to be dark. Forget Earth, it's going to be dark for another 7 minutes in Mars, and then suddenly it goes dink, and all the nights are, yay, the sun. And then it goes to Jupiter. Now to Mars to Jupiter, look, it's 13 minutes and 43, so that's another half an hour. So Mars gets lit up. Half an hour later, Jupiter gets lit up. And then from 43 to 120, so that's what, 17 minutes to an hour, another 20, that's 37. Another 37 minutes gets to Saturn, and Saturn finally lights up, all right? So from start to finish, boom, sun comes back on. Let's go to the end planet. It's going to take 1 hour 20 for that sunlight, once it's switched back on, to reach Saturn. Houston, I have a problem. We've got the speed of light, right? Do we have the speed of dark? Don't worry, that's irrelevant, that's for another day. Now look at this. watch this. And we put you, since you've all got season tickets, you'll get the best seat in the house for this. All right, so you're looking out of your window and the sun has gone out. All right, now get ready for those planets. Right, here we go. All right, now the sun is out. The planets are up there. We know they're up there. We can't see them. And then the sun goes on. Look. Let's do that again. That's light. Now, is it logical knowing when you look in the night sky, when those planets are lined up, right? When those planets are lined up, and the sun is behind us, we can see all 5 planets with the naked eye. You don't need a telescope, right? If you know where Saturn is, you can see it with the naked eye. You can see Mercury, Venus, Mars, Jupiter, and Saturn with the naked eye. How can it take, if the sun sparked up, 1 hour and 20 to reach the 5th planet, an hour 20, when we can see all of them without a telescope, with the naked eye? They're up there. It's really going to take 8 minutes to reach us, 1 hour 20 to reach Saturn, that we can see with the naked eye. Because Saturn is 1,461,000,000 kilometers away. Can't see that, sorry. Now, do you see where I'm at? Saturn is the furthest planet that we can see with a naked eye, and it can be seen, right? The one with the rings. 1,461,000,000, nearly 1.5 billion, right? We can see that with the naked eye. Don't need a telescope or a pair of binoculars, right? But we are led to believe, even though we can see all 5 of these planets when they're lined up with the naked eye, is it logical to think that it takes 1 hour and 20 minutes to reach something that we can see with our naked eye? It isn't logical. Our sight, when you go up like that, boom, and you know where Saturn is, you're looking at 1.4 billion kilometers away in an instant. Dunk. All right, it's light coming off of the sun. Fair enough. But 1 hour and 20 to reach it. If the sun went out and we're looking at Saturn, would it take 1 hour and 20? Would it take 1 hour and 20 if the sun went out, right? For the darkness to reach Saturn? Sun goes out, would it be just like what they say the light is? 3 minutes later it gets dark. Venus, it gets dark. Earth, it gets dark. And we ring to Jupiter, guys, you've got like 10 minutes before it. Mars, it gets. If it goes dark, right, Nearly. If it goes dark, doesn't it just go dark? When it gets light, isn't it just bang everywhere? It just is. Is dark and light not just like eyesight that just poof? It's either there, it's either light or it's dark. Speed of light? Science lovers. Told you it was going to be good. The speed of light. It's almost like to be or not to be, isn't it? Tell me it isn't. It's either light or it's dark. Does it travel in between? An hour and 20 minutes to reach the 5th planet. I'm telling you folks, it's not very logical. Don't forget, you saw the planets lined up not too long ago. Was it last year? You can see Saturn with the naked eye. Little rock, 1.4 billion kilometers away. You can see it because the sun is shining on it. If the sun went out, would it not just go dark like this everywhere? And when the sun lit up, would it not go poof, light everywhere, or would it travel at 299,792,000 kilometers per second? Science or not? Old Roma, 1676. It's stuck since then and it hasn't changed. Maybe they need to change it to the speed of sight. It's either dark or it's light. When the sun comes out, it just goes bang, and anything in its way casts a shadow. Question the narrative, folks.